All right, we're back talking about quadratics again today. This is section 6.1. We're going to tackle part 2 here, and I'm going to do most, if not all, of the story problems with you. Please follow along, do the problems on your paper. This starts on page 291. We're going to talk about how to think through these word problems. There's a couple things to think about. All right, I'm on page 291, problem number 44. If you need to pause the video, do that, and then come back with your book opened up and ready to read along with me. All right, problem 44. It says, architecture. The shape of each arch supporting the exchange house can be modeled by this equation, and I've written it up here, where h of x represents the height of the arch. Now usually we have y up here, but let's put h of x up here. It's the same thing as y, right? Represents the height of the arch, and x represents the horizontal distance from one end of the base in meters. Now this is a picture of the building. You can kind of see it in your book there. And there's an arch in this building that's used for support, probably also decorative of some kind. But from one end of the arch, from one end of the base of this building, we'll call it 0, and then as you go in this direction from one end of the base, this direction will be our x values. All right, number 44 says, write the equation of the axis of symmetry and find the coordinates of the vertex. Okay, well, we need to find the equation for this axis of symmetry. Well, we're going to use that formula, negative b over 2a. Now, you can use your calculator if you need to here. But negative b, okay, this is a x squared plus bx, plus you don't see c out here, so it's 0 really. B is 2, so negative 2 over 2 times a, which is negative 0.025. So go ahead and punch that in your calculator, and you end up with negative 2 over negative 0.05, which turns out to be what? All right, so you end up with 40 there. If you did not get 40, make sure that you put this entire, if you punch this in, you put the entire denominator in parentheses. Otherwise, your calculator will give you the wrong answer. Don't forget that fraction bar line here acts like a parenthesis, so you got to use your calculator's parentheses. So it tells me that the axis of symmetry right here is at x equals 40. So this is 40 across here. Well, that would mean if that's the axis of symmetry and this end is 0, that this end has to be 80. Double that, right? Now let's see what the question asks. It says, write the equation of the axis of symmetry. Okay, well, we found the axis of symmetry. The axis of symmetry is x equals 40. And then it says find the coordinates of the vertex. Okay, well, the vertex, I'm going to use capital V here, is I'm going to take 40 and stick it back in here in my equation, and I can use my calculator to do that. So I'm going to. Okay, so I went ahead and punched it in here. A was negative 0.025 times x squared. It's going to square the 40 first, plus 2 times 40. And it turns out that my y value here is also 40. So this point at the vertex has to be 40, 40. 40 went in, 40 came out. Let's take a look at the picture here. So on my graph, this point here has to be the ordered pair. 40 is x, and 40 for y came out. So the vertex is at 40, 40. Okay? So that answers our question for number 44. Let's take a look at question number 45. If you need to pause and look at that again, go ahead and do that. Number 45 says, according to this model, what is the maximum height of the arch? Well, looks like from the picture here that our arch is, end of this is at 0, so the height has to be at 40. So the height is also the maximum height would be at the top here. Again, max is that at same place at the vertex. The height, max height, is 40. I don't know if that's meters or centimeters or feet. 40. It says it's in meters, 40 meters. Okay. So the max height. Remember, the maximum is found at the vertex. Okay, on a parabola that opens down like this. All right. Any questions about that? No, that's the answer to number 45 here, and these two are the answer to number 44. Let's take a look at the next one involving gravity, and it's a big deal. Okay. All right. Turn the page. We're on page 292 now. We're going to take a look at problems 46 and 47, and these problems are your first introduction into working with gravity, something that's happening with gravity. There's a formula involving x squared that we're going to have to not only know, you're going to have to memorize this too. Take a look at number 46. Read along with me. Physics. An object is fired straight up from the top of a 200-foot tower at a velocity of 80 feet per second. Well, let's draw a little picture here while we're at it. Here's a tower. Okay. An object is fired straight up from the top of a 200-foot tower. Let's call the bottom of that tower at 100 or 0, and let's call the top of that tower at 200 feet. By the way, this gravity formula works with feet. There's another one that's similar to it that works with meters. This object is fired straight up. So they shoot it up in the air, and then it's going to come back down. Okay? Going to come back down. We're creating a parabola, in fact, that's going to happen here. Let's show you why. It's fired up at a velocity of 80 feet per second, so it's shot off. Its velocity is 80 feet per second. Okay, velocity. Velocity. Am I spelling this right? Velocity. Yeah, velocity. That's its speed. It's shot off at 80 feet per second. So depending on how strong the cannon is or how strong the weapon is or whatever you're using, it's going to shoot it off in the air at a certain speed. Okay? Or if you threw it up, you'd be throwing it up at a certain speed. Then it says in the problem, the height h relative to time of the object t seconds after it's fired is given by this formula, -16 t squared plus 80t plus 200. Now, we're going to use this formula here to talk about the basic general formula for gravity. This is the formula for gravity. All right, now, I want you to notice that there's a couple things in here that are never going to change. In a gravity formula, it's always going to be t squared. T stands for time, so let's put t down here in terms of time. Okay, time is t. And as time elapses, the height changes. As time goes on, the height of that particular object changes. Right when it's fired, it's at 200, but then after that, it goes up and then it comes back down. And the reason it's coming back down, of course, is because of gravity. There's a number in here that is never going to go away. It's -16. The number -16, it refers to the force of gravity in feet, 16 feet. So in other words, the first second you drop something, let's say we drop an object. Okay, let's just drop an object off the top of this building. If we drop an object off the top of the building, the first second it drops 16 feet. Okay? Then after another second, the second second, it drops not just 16, but 2 squared is 4. 4 times 16, or 64. Now, we know that this is true, that the longer something falls, the faster and faster it goes. That's why you can jump off of a table and you're not in the air very long, so you don't hurt yourself. But if you were to jump off a building, you know, like the height of the school or something, you would probably hurt yourself because you're now in the air longer and you're traveling faster and faster. This squaring is that property that causes gravity to increase at a certain speed. Gravity speed squares every second. So you go 1 second, you'll drop 16 feet. You go 2 seconds in this problem, 2 times 2 is 4. 4 times negative 16 is 64. If you dropped it 3 seconds, we don't have enough room in the building here, but 3 squared is 9, and 9 times negative 16 is like 144 feet or something like that. It is enormous that the longer you fall, the faster and faster you go. Okay? So this number 16 has to do with the speed of gravity, and the fall, and that's relative to feet. That's in feet. Okay. The number 80 here happens to be what's called the initial velocity. The initial velocity, and that's what they told us, was that they shot this thing off at a certain speed up in the air. The initial velocity, 80 feet per second. You'll notice that 80 feet is positive here. That's because it was being shot up in the air. Up is positive. But if it was a negative 80, that means they shoot the cannon down. It would be going downhill. And then in this case, the number 200 is what we call the initial height. The initial height. How high was the object when the clock started? Well, the clock started at 0 when the object was at 200 feet. So you can see that each of these numbers represents something in the problem, which gives us our basic formula. You'll need to memorize this formula, and here it is. Negative 16 t squared plus initial velocity. The v sub 0 means the velocity when time is 0, times the time, plus the initial height. Again, that's the height when time is 0. H sub 0 is the initial height. This formula, you'll need to put it in your notebook, put a big box around it. It is the basic formula for gravity in feet. So we're going to be using this. You'll need to know it. You're going to plug in, for v sub o, you're going to plug in that initial velocity. For h sub o, you're going to plug in the number of the height when you shoot the thing off, or when time starts. That's what the 0 stands for, is when time is 0. 0, velocity in time is 0, height when time is 0. And what all that gives you is the final, or the output height of the object. So this is a formula that we're going to use, and we're going to go ahead and finish this problem using this formula. So let me erase here and we'll go back and do the problem. All right, let's read the question again. It says, find the maximum height reached by the object. Well, the maximum height has to be the height right here at the top. It gets up to the top, it kind of slows down, and then it turns around and comes back. That maximum height is at the vertex. So when it's asking for the maximum height, it's asking for the vertex. So we need to find that vertex, and we're going to use our formula, negative b over 2a. So here we go. The vertex is negative b. So that would be a negative 80 over 2 times a. 2 times a negative 16. That's negative 80 over a negative 32. And we end up with positive 2.5 seconds. So when the time is 2.5 seconds, that's when we hit the vertex x value. So our ordered pair is going to be 2.5 something. We know that the x value, that's what x stands for, the x value is 2.5. Now we need to find the height. Well, that is not the height. That's the time. The height at that time we're going to have to find by plugging 2.5 into this equation. Now you can do it here with your you can do it with your calculator, or you can do this manually. I'm going to just go ahead and do it with my calculator here. So we're going to plug that value into our equation here. So or we could even use a table if we wanted to. But let's go ahead and plug it in. So I got negative 16 times t is 2.5 squared plus 80 times 2.5 plus 200. And it says that I'm 300 feet. 300 feet. So when the time is 250, the height is 300 feet. You need to do that again. 300 feet. So what it's telling us is that it started at 200, and when it got to that top, that maximum, this was now 300 feet. So it went up 100 feet, and then it started to come back down. Okay? So our answer for number 46 asks, what is the maximum height and the time? Well, there they are. The time is 2.5. This is answer to 46. And the height was 300 feet. 2.5, 300. That's where the vertex is. You can see that knowing how to find the vertex is going to be critical. Your ability to find that vertex is helped by the fact that you know the formula x equals negative b over 2a. Got to know that formula. All right, let's take a look at problem 47. And 47 says, interpret the meaning of the y-intercept in the context of the problem. Well, let's look back up here. See the y-intercept? The y-intercept is right here, okay? Because if x is 0 or t is 0, these both go out. They're gone. So the y-intercept is at 200. And you can see it from the picture here, too, that the y-intercept is at 200. Well, what's the meaning? Well, the meaning of the y-intercept is that it is the initial height. The initial height. In other words, when the clock starts, what is the initial height of the object? So the y-intercept is the same as the initial value, the initial height. And that is something that we've kind of used to seeing in linear equations as well. Okay? Well, if you need to read that again, or rewind that again, let's go on to the next problem, number 48. Okay? All right, let's take a look at problem 48, 49, and 50 here. It says, Steve has 120 feet of fence to make a rectangular kennel for his dogs. He will use his house as one side. And you can see from the picture over there, here is Steve's house. And he's going to make some fencing here. He's going to use the house as one side of his fence. And he has 120 feet of fencing. Well, he needs to know where to put these posts so that he can create this fence. So he needs to know the dimensions of this particular thing so he knows where to put the posts. He's only got so much fencing, but he wants to use all the fencing. It says, Steve has 120 feet of fence to make a rectangular kennel for his dog. He will use his house as one side. Write an algebraic expression, number 48, for the kennel's length. Well, if you look at the problem that they give you in the book, they're telling you that let's let this width be x. Now, we don't know exactly how big this is, but we do know that if x is the width, the length, this length here, is going to have to be 120 feet of fencing minus both of those x's. This length here if he's got 120 feet of fencing, has to be 120 minus these two x's. So you're going to take out those two chunks of fencing, and then this has to be the length of that side. So if the width is x, the length is 120 minus 2x. So that's the answer to number 48. Okay. Number 49, write what dimensions produce a kennel with the greatest area. Okay, well, the area is what they're concerned about. They want the biggest kennel possible. Well, there's lots of different things you could pick for x. You could pick a small number for x or a big number for x. Remember, if he picks a really small number for x, this length is going to be longer. And if he picks a real big number for x, then this kennel is not going to be very tall here. It's going to be pretty skinny. He wants to be able to maximize the area. Well, the area of this rectangle is found by taking the length times the width. I only need one of the x's. There is the area of the kennel. Okay? Now, that's a formula that you can use to find the area of the kennel. Okay? And so let's expand this by using some algebra here. I got 120x minus 2x squared, or if I rewrite this, it's negative 2x squared plus 120x. Okay? Now, looking at this equation right here, this is a parabola because it's x squared. It's a parabola. It's a quadratic. And in fact, not only is it a parabola, it's a parabola that has to open down because of this negative here. Now I'm just going to draw a sketch in here. That parabola has to open down. That means that negative a value means the parabola opens down. So when the question asks for the maximum area of the comment, by the way, this is the answer to 50 right here, or 49, excuse me. This was 49. Okay, and so number 50 is asking for what are the dimensions, find the maximum area of the kennel. Well, where is a maximum found on a parabola? Well, it's found right here at the vertex, isn't it? So I need to know where that vertex is, and good news is I have a formula for it. We're going to use the formula, the x equals negative b over 2a. Well, that would be a negative 120 over 2 times a negative 2, or negative 120 over a negative 4, or turns out to be, what, 30. So this x value has to be 30. The dimensions are 30, 30, and 30. So the dimensions of this particular rectangle has to be 30. 30 there and 30 here. Well, then what would the length be? Well, let's see. 120 minus 2 30s. 120 minus 60 gives me 60. So we see that this other length here has to be 60. 60 and 30 adds up to 120, and that's exactly right. So now what you'll notice is that there's lots of different combinations that Steve could have picked for his length, but the one that produced the greatest area is the one that's right at the top of that parabola. Remember, this parabola, this A happens to be the area, and so the area, the height, the area is equal to the width, is relative to the width, and so that vertex tells us where the maximum is. On these problems, when you see the word maximum or minimum, you've got to know, oh, I'm looking for the vertex, because that's at the top of the graph if it's maximum. Or if it was opening up, it's the bottom of the graph. So there you go. Our answer is the dimensions are 30 by 60. But the question asks, find the maximum area. Well, what's the area? 60 times 30. Well, the area is length times width, or the area has to be, what is that, 1,800. And that is feet. Yeah, this is square feet. Square feet. Okay? So once again, you're using this idea of negative b over 2a to help you find the vertex. And they're asking for the maximum. Anytime they're looking for the maximum, you're looking for the vertex. All right, let's take a look at the next one. All right, problem 51 and 52 are problems that are like the ones that's an example in your book. This is a bit challenging problem. It's something that you may not be intuitive to find out, but let's go ahead and do it together. Read along with me. A tour bus in the historic district of Savannah, Georgia serves 300 customers a day, and the charge is $8 per person. The owner estimates that the company would lose 20 passengers a day for each dollar fare increase. Now, if you're in a business, you're always playing this balancing game of I want to raise the price if I can to get the most from each customer. I want to raise the price if I can, and if I can raise the price, will that affect how many people come to my business? You know, if you increase the price, people are going to get scared away and they'll go somewhere else. Or maybe they'll just say, well, I don't need it that bad. I mean, if you charge somebody $100 for a bus trip around Havana, nobody would want to do that. It's too expensive. But $8, well, that's a pretty good price. But if the guy's got a business and he wants to make as much money as possible, the maximum amount of money, there's that word maximum, then can we raise the price? Well, it says according to the problem that if he raises the price $1, raise it up $1, then he's going to lose customers. And it says he's going to lose 20 customers. For every dollar increase, he's going to lose 20 passengers, 20 customers. So we want to figure out how many price increases could this guy do and still get the maximum profit. See, he's getting more money because he's raising the price, but he's got fewer customers, so that's less money that way. We want to find out what the maximum is, and as it turns out, we're going to use a parabola, a quadratic here, to solve it. So number 51 says, what charge would give the most income for the company? Well, what we need to realize is that if we let x equal the number of $1 price increases, okay, the number of $1 price increases, currently he's charging $8 plus those price increases. One price increase would be here, okay, and this is his price, and if he multiplies his price times the number of customers, that'll give him how much money he makes. Well, he started out here with 300 customers, and every price increase he makes, he loses 20 customers. So minus 20 customers for every price increase. 20 customers for every price increase. So if he increases it $1, 20 times $1 is $20. So now he's only got 280 customers. But he's charging $9 now. Or let's say he raised it 2 price increases. Now he's charging $10, and 2 times 20 is 40. He's going to lose 40 customers. That means he's now only got 240 customers, but he is charging more money. So this is actually going to be the equation that we want on how much his profits are. He wants to make sure that he gets the most income. Actually, they use the word income here, not profits. So income. Well, you'll notice that if we go ahead and set this up, price times customers, we find that we're going to end up with a quadratic here. How so? Because when we FOIL this, we're going to get an x squared. Let's do it. Foiling. Okay, so this is income is based upon this FOILed number. Let's rearrange this and simplify. Negative 20 x squared plus 140x plus 2400 equals his income. Negative 20x squared plus 140x. Make sure I did the arithmetic right here. Looks like I did. Okay. Now you'll notice that this equation that we have here is a quadratic. It's got an x squared in it. And it also opens down. So this parabola is going to open down again. Well, when it's opening down, that means that this vertex happens to be the maximum income. He wants his income to be the maximum. So the hard part about doing this problem is getting this first part set up. You have to let x equal the number of $1 price increases. And that's not obvious. Most people can't see that one right away. And then you can see that the price times the number of customers is going to be how much income he gets. So how do we find that maximum? Well, it happens to be at the vertex. So let's go ahead and use our formula, negative b over 2a. And we end up with, let's see, negative 140 over 2 times a negative 20, or negative 140 over negative 40. The negatives go out, and we end up with, what, $2, what is that? Cancels here. We end up with 7 halves. Oops, 7 halves. 7 halves, right? Yeah, 14 over negative, which is 3.5. So x is equal to 3.5. What's it telling us? Well, it's telling us that if he has 3.5 $1 price increases, he'll maximize his profit. He could get more profit, by changing it 1 or 2 or 3. But right at 3.5 price increases, he gets the best profit because even though he's raising his price a certain amount, the customers haven't been dropping so badly. Okay, so there it is, 3.5 price increases. So what's our answer? Well, if he started out at $8 for a ticket, then if we add 3.5 price increases, or $3.50, turns out that if he charges $11.50, he will make the maximum profit. You can see that this particular problem is very helpful in business, that you're able to calculate, okay, I want my maximum profit. If you can make some estimates about, how many customers are you going to lose and so forth, do some research, it's really helpful for a person to figure out, well, what should I be charging and get the maximum profit? All right, now the final answer here, number 52, I'm going to raise this up here so I have some room here. Number 52 says, what is it if the company raised their fare to that price, how much daily income should they expect to bring? Well, if X is $11.50 now, or excuse me, the new price is $11.50, how many customers do they get? Well, let's take that 3.5 and stick it back into our equation. And I'm going to do that with the calculator. Be just a little bit easier than having to do the arithmetic. Okay, so I'm going to clear this. I'm going to stick it into our equation here. Okay, so I've got negative 20x squared. In this case, x happens to be what, 3.5? Yeah. Times, let's see here, negative 20 times 3.5 squared plus 140 times 3.5 plus 2,400. And I end up with a dollar value of $26.45. Now, we don't know how many customers he has, but we could figure that out here. We could figure out how many customers he has by multiplying 20 times 3.5. That's 60, 70. Turns out he's got 200 and what? 3.5 times that's 670. Yeah, turns out he's got 230 customers. And we could figure it out that way too. Just to double check that, let's take his $11.50 that he's now charging times 230 customers, and yeah, we get the same amount. So the hardest part about doing this is getting this initial setup right here. Is understanding that he's adding to his price by a certain number of price increases. The let statement is really the key to this whole thing. All right, I'm going to let you do 53 on your own as part of your homework. And you've done most of these with me, so this assignment's just a matter of walking through it with me. But just do one more yourself, and then we're going to move on to the next section. Make sure you know how to find the max and the min and using this formula, negative b over 2a. All right, let's take a look at your assignment. Well, we already looked at your assignment for tonight. You just got to do problem 53 now. So I'll check with you next time on section 6.2. Have a good one.